Alright, this video is the last part, the fifth and final part of our lesson on factoring polynomials and finding all of the zeros. Why is this so small? Interesting. Well, let's get on that number 9. When I see a little trinomial like this, I think about just factoring it. So let's definitely give that a try. See what happens. X squared can only be x times x. I'm looking at the 10. It's either 2 times 5 or 1 times 10. Based on the fact that I see a 9 there, I'm sort of liking the 1 times 10 option. So let's try that. So 1 times 10. Look, inner I have 1x. Outer I have 10x. Trying to get a positive 9, so I would need a positive 10 and a negative 1 for that. So there's my negative 1, there's my positive 10. Luckily, a negative times a positive is a negative, so that checks out. So I did factor it correctly, so great. Now I need to keep going. Well, first of all, let's go ahead and just copy this over to the answer box. So x minus 1, x plus 10. Those are the factors. Okay, great. And of course the roots will just be 1 and negative 10. From if I set these equal to 0 and solve, there you go. So, quickest problem ever. Let's just mention the fundamental theorem of algebra. If the power, the degree is 2, then there should be 2 zeros, 2 roots. And there they are. Okay, by the way, the difference between zeros and roots. Equations have roots. So see the equal sign, equals 0. So that's why I wrote roots for number 10 and for number 9. Functions, on the other hand, have zeros. So that's why, well, it's covered up by my little sign there. So for example, number 6, if I look at the answer box, it should say zeros, because functions, f of x, functions have zeros, but equations have roots. Okay, that's why number 7 has roots, and number 6 has zeros. Okay, just educating y'all. It's kind of my job, I guess. So let's go and do the last one. Alright, because this is getting redonkulous. There are too many of these for any kind of grouping, so let's consult the calculator and see what we can find out. Okay, so I've typed in the calculator. I always start at negative 10 because the zeros rarely go beyond that. And I can just scroll down from there, looking for zeros on the y side. And there's 1. So let's use that. Okay, so down comes the 2. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, are we seeing any patterns here? Maybe I could do grouping. I think I do see a pattern. Okay, the pattern is this number is double this number, and this number is double this number. And they both have opposite signs. So I'm thinking grouping is going to work. So let's rock that. So first of all, what we have here is 2x to the third power minus x squared plus 6x minus 3. Okay, Yeah. Meanwhile, we have from this 0, we have a factor of x minus 1. Let's never forget that. Okay, so grouping means let's pair the first two terms, let's pair the second two terms, pull out the GCF. So common factor here, the only thing I've got really is the x squared. Okay, it will be helpful to you if you look at this as 1x squared, so there's something you can see left behind when I take the x squared away, because that's what I'm going to do. So I've got x squared out front of some parentheses, and that's going to leave behind 2x minus 1. Okay, now over here, these are both divisible by 3, so I'm going to pull out a common factor of 3, and dividing both of these by 3 is what I'm really doing now. Will give me 2x minus 1. Oh look, it's the same thing twice. Kind of necessary if we're going to do grouping. So let's factor out the common factor of 2x minus 1, and I like to put that out front. So there's my 2x minus 1. That is going to leave behind the purple stuff, x squared plus 3. Okay, and once again, let's just bring down the x minus 1. Can I factor any further? How about this quadratic factor? Can this factor further? No, this is a sum, and this is not even a perfect square, so even if it were subtraction, I still couldn't factor. So this is completely factored. I'm just going to copy this up to the answer box. Alright, so these are the factors. And of course my roots are 1 from that. Okay, if I set the 2x minus 1 equal to 0, that'll give me 2x equals 1, x equals 1/2. So I've got a 0 of 1/2. Similarly, if I set the x squared plus 3 equal to 0 and solve, that's going to give me x squared equals negative 3. And then it would be time to take the square root of both sides. Do not forget your plus or minus. So that's going to leave me with x equals. Now, look guys, I've got a negative under the radical. That's going to be plus or minus I radical 3. Alright, only I'm going to write this separately as I radical 3 and negative I radical 3. Okay, I do believe problem number 10 here, that was the last problem of this lesson. Last problem of this entire series. I do not want to add up how much time I spent on this. But it was too much. I need some sleep. Alright guys, I hope this stuff is helpful. I didn't actually get this video posted until the day the homework was due. So only my procrastinators will ever even see this. But for what it's worth, here it is. See you on the next video, guys.